Yes, hello students. In this lecture, we shall try to find out what is the mode of conduction. In the previous two lectures, we have seen that the conduction can be continuous or it can be discontinuous. And how to deal with both the problems, we have learned. How to find out the average value of the output voltage in the case of continuous conduction and in the case of discontinuous conduction. But now we have to learn how to find out whether the conduction is continuous or it is discontinuous. So knowing that, you can find out what is the average value of the output voltage. So we have seen that the current rises like this in the case of discontinuous conduction and becomes 0 at omega t equal to beta, and we have seen that larger the current, less chances for discontinuous conduction. As the load is increased, the load torque is increased, the current has to rise, and more current means more energy is stored in the inductance, and the later it will fall to 0. So if the load torque is increased, after certain load torque, the conduction becomes continuous, and that torque for which conduction is just becoming continuous is known as critical torque. Torque above than critical torque will cause continuous conduction, and the torque is less than critical torque, it will be discontinuous conduction. So as you increase the value of load torque here, current will increase for same alpha, it will increase and it will fall to 0 at a later stage. Further increase in the torque may cause the wave shape to become like this, and it will just become equal to 0 at omega t equal to pi plus alpha, and this means that after that again current starts increasing. So this is not discontinuous conduction, you can say it is the critical conduction. Any increase in torque above that will cause the conduction to become continuous like this. So that torque is known as the critical torque. So this approach is used to find out whether the conduction is continuous or discontinuous. As you load the motor, the torque increases and the speed decreases. This you know. So the corresponding speed at which the conduction becomes discontinuous is known as critical speed. That is the speed corresponding to critical torque is known as critical speed. So let us try to find out the expression for critical speed, and if the speed is more than critical speed, conduction will be discontinuous. If the speed is less than that critical speed, the conduction will be continuous. So in that way you can find out whether the conduction is continuous or discontinuous. So recall the equation that we derived in the previous lecture. I omega t equal to Vm by Z sin omega t minus phi minus sin alpha minus phi e to the power minus beta minus alpha cot phi. Phi, recall, is the impedance angle, minus E upon Ra 1 minus e to the power minus omega t minus alpha cot phi. So this was the expression of current in terms of omega t, and what is the value of current at omega t equal to beta? This you can obtain by putting beta in place of omega t. Okay, so here also we have this beta. So this is the value of Ia beta, the value of Ia at beta, and that you know that it is equal to 0. So in the case of critical conduction, when conduction is just becoming continuous, then the value of beta will be equal to pi plus alpha. So this is the condition at critical condition, critical conduction. Beta more than this will cause continuous conduction. So for that condition, you just put beta equal to pi plus alpha in this equation, and that will be corresponding to critical conduction. So instead of beta, you write here pi plus alpha. pi plus alpha, and that is the critical torque, and the corresponding speed is the critical speed. So TC, we call it a critical torque, and the corresponding speed EC, corresponding back EMF, you call it the EMF at critical speed. So this is equal to K times omega mc, where omega mc is the critical speed. So if the speed is more than this speed, conduction will become discontinuous. So in that case, you just put here, instead of E, you write E equal to K omega mc. So at critical conduction, this is the equation, and this current is equal to 0. So this is IA pi plus alpha is equal to 0. So this means that here everything is known to you, and you are interested in finding out what is the critical speed. You can solve for omega mc, and this equation I will just write it here. So this equation for critical speed comes out to be, this is Vm Ra upon Z K sin alpha minus phi and this is 1, we write it like this, minus pi cot phi plus 1 minus 1. So this is the speed at which conduction is just going to be changed from continuous to discontinuous conduction mode. So this is the expression for omega mc, critical speed. So how to find out whether the conduction is continuous or discontinuous? For given a value of alpha, you find out the critical speed. So everything is known to you, the motor constant K, Z, Vm, alpha, phi, everything is known to you. Find out the critical speed, and if the motor speed is greater than omega mc, this implies that the conduction is discontinuous conduction. On the other hand, if speed is less than omega mc, this implies that the conduction is continuous. Similarly, you can find out, in some cases you can find out what is the torque. So if the critical torque, if the motor torque is greater than the critical torque, then conduction will be continuous. On the other hand, if the motor torque is less than critical torque, the conduction is discontinuous. So this means that for higher torques, the conduction will be continuous and the corresponding speed will be less than the critical speed. So you can say that if you see the speed torque characteristics of the motor is like this, that you have seen earlier. So after a certain value of torque, the conduction becomes continuous, and before that the conduction is discontinuous. So in that way you can find out the whether the conduction is continuous or discontinuous, and then you can proceed with your problem and find out the value of beta in the case of discontinuous conduction, and then you determine the value of BA and you can solve the problem. So this is how we can find out whether the conduction is continuous or discontinuous. So that is all for today. Thank you very much.